PLC programming pump control examples. In this presentation, we're going to be looking at some basic discrete inputs and outputs, some internal bits, and perhaps even a latch and unlatch feature in the control of a simple pumping application. The first motor pump control application is going to be for a pump down type of system, which means we are emptying a tank of fluid. Now we're only going to use a single float switch for this particular installation. And as is quite common with this type of application, we're going to have a handoff auto switch that allows us to control the motor in either an automatic or simply to turn it on as in the hand position. Here's the installation. We can see physically the tank with the pipe that's pouring water into it at the top of the screen. The pump is off to the right-hand side, and there is a float switch that's located near the top of the tank. On the left-hand side, we can see the actual wiring of the PLC inputs and outputs with the field devices, and then the program on the right-hand side. We're going to set the handoff auto switch to auto and energize the system, at which point we should see that both input 2 and input 8 should go true. Now, as water starts to pour in, we will see that at some point we will reach the threshold level for float switch 1, at which point it will close. When it closes, voltage is applied to input 3 on the PLC, which will cause the examine if on input 3 to go true. This will allow for a full line of logic to then apply to this rung, and we have an output that will go on, causing the motor to energize. Now the pump will come on and it will continue to pump until the float switch opens, at which point the high input 3 will go back to false and the output will de-energize, causing the motor to turn off. Now there is some disadvantage to this type of system, and that is that the float switch requires a significant length of cord if we want to have a significant or large fluid height movement. Inevitably, long unsecured cord lengths tend to lead to tangling of equipment. To combat this problem, most often on larger pumping applications, we have two separate float switches, a high float switch and a low float switch. This is a very similar program, but what we have added into it is a second float as well as a holding contact from my motor starter, which is indicated on input 7. We will turn it to the auto position with the handoff auto switch, and immediately we notice that input 2 and 8 are energized, meaning that input 2 and 8 will go true in my PLC program. The water level will start to rise, and it will first hit float switch 2, which will cause it to close and energize input 5, causing input 5 to go true. The water level will rise yet again until we reach float switch 1, which will close, energizing input 3, which will again cause input 3 to go true in the PLC program. This allows for a full rung of true logic and M coil output 0 to go on and energize the motor, turning the pump on. At this point, the motor starter holding contact will close, causing input 7 to be energized and to turn true in the PLC program. The water level will now start to drop, and as it does, float switch 1 will return to its original position and cause its input to go back to a false state. The water level will continue to drop until float switch 2 returns to its original state, at which point input 5 will go false, and this will then prevent a full logic expression or a full true statement from being applied to the coil, which means the coil will turn off and the motor starter holding contact will go back to its open position, and the input 7 contact or input symbol in my PLC program will go back to a false condition.